Hi, and welcome to the game of Mastermind. For our next major project, we're going to program a mastermind game using C#. And one of the first things I wanted to do was describe the actual board game itself, describe the rules to give you an idea of what it will take to implement this in Windows. First of all, the game is played with two players, a code maker and a code breaker. The code maker starts first, and he creates a secret code of 4 colored pegs. The colored pegs are right here, and they're one of 6 different colors. So let's say that I'm the code maker, and I'm going to create a secret code here. Like that. Now the code breaker can't see what I just did. And so we're going to cover this up, and then we're going to invite the code breaker to guess what the secret code is. So what the code breaker does is he sits on the other side of me, and he will try to guess what the code is. So he's going to pick some pegs. Then, here I'm going to remove the barrier so that you can see what's going on, so I can explain the logic a little bit. So now the code maker has to give the code breaker some feedback as to how close his guess was to the secret code. So the first thing the code maker does is he looks and sees if there's an exact match between the pegs, between the guess and the secret combination. And lo and behold, the third peg is white. So that's an exact match. And we indicate an exact match with a red peg. Now when the code breaker sees this, he doesn't know which of these pegs is correct. All he knows is one of them is. And then, so after the code maker checks all the exact matches, those are basically eliminated from our selection process. And now he looks at the remaining pegs to see which colors are correct but in the wrong spots. And looking only at the remaining pegs, he sees if there are any colors that were guessed correctly but are in the wrong spots with respect to the secret code. And we see that we have one. The first peg in the guess is green, and there is a green peg in our secret code. So for every color that is correct but in the wrong spot, he places a white peg in the right hand side. Okay? So now the only thing that the code breaker knows is that one of these 4 pegs is the right color in the right spot, and a different one is the right color but in the wrong spot. So now he has to guess. He doesn't know which, so he's going to have to try a different code and see how that changes. So say he decides to keep the green the same. He thinks the green is the one in the right spot. And he's going to change the purple. He's going to move the white to over here. Let's say he does another green right here. Okay, so now let's look at this situation. Now the code maker looks and he sees there are no exact matches, correct? So no red pegs. Now how many colors are the same but in different spots? Well, we have the green again, but wait a minute, we have 2 greens. Does that mean we should place 2 white pegs? No, because there's only 1 green in the secret code. So once we have matched these guys, essentially, we have eliminated them from our comparisons. Then for each one of these pegs, we cannot have more than 1 red or white peg representing it. So so we had no red pegs because there were no exact matches. And we see that there are 2 color matches but in the wrong spots. the green, either green, let's say this green is in the wrong spot because there was a green here, but it's in a different spot, and the white. Now there are two whites in the secret code. We still only have one color match. So we have one green that is out of place and one white that is out of place. The other green doesn't count, and neither does the orange. So we place two white pegs. So first we look for exact matches. Green is an exact match, white is an exact match. That's two red pegs. Purple is no match at all, and neither is pink. So two red and no white. How many exact matches? We have three exact matches. So that eliminates from our comparisons this one, and this one. So now all we have left to compare is the orange to the white. It no longer matters that we have an orange in the secret code, because that orange is already matched by this one. They're already taken care of. They're already paired up. So that's done with. So as far as we're concerned, among the pegs that are left in the secret code, there is no orange. So that orange counts for nothing. So that's all we leave behind. Okay? Then of course in the end, if the code breaker is smart enough, he would guess the correct combination on his next couple guesses. So the goal is to get an exact match. So 4 red pegs. Okay? Now the question is, how do we make such a game on a computer? Well, you might say, well, let's write a really cool program where we actually show a picture of the mastermind board, and we have a pile of 3D pegs, and the person can actually click with their mouse, take one out, and place it in the slot. Ooh, wouldn't that be fun? However, that would be just way too complicated for what I'm trying to teach you and for your guys' skill and knowledge level. I'm not sure if I know how to do that. So we're going to try to keep it simple. And in fact, one of the things a programmer has to consider is how close to reality do they want their program to be. And for the sake of quickness, we're going to cut a few corners, and we're going to do things simple. And you will still there will still be lots of concepts for you guys to pick up along the way.